Hi. So today we're going to continue looking into our systems of equations. So we've learned how to solve our systems of equations using graphing, using substitution, and using elimination. So here they're giving us some word problems that we're going to have to look into, and we're going to have to solve for specific cases. So this first example, we have Ralph and Jody go to shop to buy potato chips and candy bars. Ralph buys 3 bags of potato chips and 4 candy bars. He spends $3.75. Jody buys 4 bags of potato chips and 2 candy bars. She spends $3. Later, Clancy joins Ralph and Jody and asks to buy 1 bag of potato chips and 1 candy bar for them. They need to work out how much he should from them. They need to work out how much he should pay. Ralph writes 3p plus 4b is equal to 375. If p stands for the cost in cents of a bag of potato chips, and b stands for the cost in cents of a candy bar, what does the 375 in Ralph's equation mean? So what that means is it's the total cost in cents. They want us to write a similar equation using p and b for the items Jody bought. So Jody bought 4 bags of potato chips and 2 candy bars, and that cost her $3, but in cents, that's going to be 300. So then they want us to use the two equations to figure out the price of a bag of potato chips and the price of a candy bar. So we have our two equations. We have 3p plus 4b is equal to 375. And we have 4p plus 2b is equal to 300. What I'm going to do is I'm going to use elimination. I'm going to multiply my whole bottom equation by -2 so I can cancel out my b. So I'm going to take my 4p plus 2b is equal to 300. And I'm going to multiply both sides by -2. So that's going to end up giving me negative times a positive is a negative, negative 8p, negative times a positive is a negative, minus 4b is equal to, we have 300 times -2 is negative 600. I didn't touch my top equation, so I'm going to bring my top equation down. My top equation is 3p plus 4b is equal to 375. If I add it straight down, negative 8p plus 3p is going to leave me with 5p. Our b's are going to cancel out, and that's going to leave me with negative 600 plus 375 is going to give us negative 225. This should be a negative. I'm going to divide both sides by -5. And what that's going to tell me is that my p is equal to 45. Remember, this was in cents. So that means one bag of potato chips is 45 cents. Or, if we want to put it in dollars, 45 cents. So now that I know what my potato chips are, I have to go back to one of my equations. I'm going to do my top equation. 3p plus 4b is equal to 375. And since I know that my potato chips are 45 cents, I'm going to have to plug that in. 3 times 45 plus 4b is equal to 375. 3 times 45 is going to give me 135 plus 4b, which is equal to 375. And now I have to subtract 135 on both sides. And that's going to tell me that 4b is equal to, when I subtract my 135, I'm going to be left with 240. Then I have to divide both sides by 4 because I want to get b by itself. So that's going to be telling me that b is equal to 60. So what that means is a candy bar is 60 cents. So Clancy has just $1. Does he have enough money to buy a bag of potato chips and a candy bar? Explain. So if we do one bag of potato chips, which is 45 cents, plus a candy bar, which is 60 cents, we can see that it's going to cost 5, 0, carry the 1, bring down a decimal point, $1.05 to buy both one potato chips and one candy bar. So our answer is no. He is 5 cents short. So that's with this question. If we take a look at the next question, they're telling us 2 taxi companies charge different rates. We have Metro Taxi, which costs $3 for the first mile, and then $2.50 for each additional mile. So, then we have City Taxi, which is $5 for the first mile, and $2.25 for each additional mile. They want to know, when will the 2 taxi companies cost the same? So let's write out a formula for this. So we have y, which is the total cost, is equal to, total cost, x is equal to number of miles. So for a Metro Taxi, they're telling us y is equal to $3 plus $2.50 for each mile after the first. So this is going to be times x minus 1. Because if it's only 1 mile, then our cost is just $3. Once we get to our second mile, that's when we add on an additional $2.50. Our cost for City Taxi is $5 plus $2.25 for each additional mile. We can simplify this if we want. So this is giving us, we'll say that this is for Metro because it is, and this is for City because it is. For Metro, we're going to have $3 plus $2.50 times X minus $2.50. So when we combine our like terms, that's going to end up giving us $2.50 per mile plus 50 cents. Down here, we're going to get $5 plus $2.25 per mile minus $2.25. When we combine alike terms, we're going to end up getting $2.25 per mile plus 5 minus 2.25 is going to give us $2.75. They want to know when these two are equal. So we have to set them equal to each other. We have our $2.50 per mile plus 50 cents is equal to our $2.25 per mile plus 2.75. This should be an X right here. All right, so now I want to get X by itself. So I'm going to subtract $2.25 per mile on both sides. That's going to give us 25.25x plus 50 cents is going to be equal to our $2.75. Going to have to subtract 50 cents on both sides. And that's going to give me 0.25x is equal to $2.25. Divide by 0.25 on both sides. And I'm going to end up with X is equal to 9. So when will the two taxi companies cost the same? If you use the companies for 9 miles. They want you to describe a situation in which it would make more sense to use Metro Taxi than describe a different situation when it would make more sense to use City Taxi. Explain. The best way to do this would be to draw a table. So if we draw our table, I'm going to write X. That's going to be for our miles. We have Metro, which is our Y is equal to 2.50x plus 0.50. And then we have our city, which our cost is going to be equal to $2.25 per mile plus $2.75. So we can either plug into the equation or we can make this chart based off of what they're telling us here. So let's take a sampling. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to stop there. We know that at 9 miles they're going to cost exactly the same. So let's see what happens. So with Metro, for the first mile it's $3. With City for the first mile, it's $5. I'm going to fill out Metro first. We're adding $2.50 each mile. So this is going to end up being $5.50. Then we're going to end up getting $8. Then we're going to end up getting $10.50. Then we're going to end up getting $13. Then we're going to end up getting $15.50. Then we're going to end up getting $18. Then we're going to end up getting $20.50. Then we're going to end up getting $23. Then we're going to end up getting $25.50. So that's for Metro. Now let's fill out the City. So for each additional mile, we're adding $2.25. So this is going to be $7.25. Then we're going to get $9.50. Then we're going to get $11.75. Then we're going to end up getting $14. Then we're going to end up getting $16.25. Then we're going to end up getting $18.50. Then we're going to end up getting $20.75. Then we're going to get $23. Then we're going to end up getting $25.25. So what we can see is if we're using our taxi service anywhere between 1 mile to 8 miles, Metro is cheaper. At 9 miles, they're both the same. So it doesn't matter which one we use. Anywhere from 10 miles and onward, we're going to see that our city taxi is better. So that's what's happening here. If we take a look at this situation, Bill wants to order new jerseys for his baseball team. He sees the following advertisements for 2 printing companies, Print It and Top Print. With Print It, get your baseball jerseys printed with your own team names here. Only $21 per jersey. With Top Print, you need to supply them with your design, pay a one-off setting up cost of $45, meaning you have to pay $45 plus $18 per jersey. So give Bill some advice on which company he should buy from. Explain. So with this one, we can set up a chart. I'm going to say X is the number of jerseys we order. We're going to have Print It, and we're going to have Top Print. We're going to end up seeing that if we're making a chart, this is going to go for a long time, this chart. So what I did when I was solving it was I want to see, is there a point where these 2 companies are going to be the same? So I said, all right, well, for my first company, our equation, the cost is going to be equal to $21 times the number of jerseys we buy. For our second company, the cost is going to be equal to $18 times the amount of jerseys we buy, plus that initial startup fee of $45. So I said, all right, well, since we have the cost and the cost, I want to figure out where the cost is going to be the same. I set my $21 per jersey equal to the $18 per jersey plus the $45 startup fee. I subtracted 18x on both sides. So that's going to end up giving me 3x is equal to 45. Divide by 3. Divide by 3. That gave me that they'll be the same if we use either company for 15 jerseys. So now in my table, I said, all right, well, let me get a little bit of start. 1, 2, 3, 4. Oh, that should be a 4. Then 5. Then I said, all right, well, this is going to give me a little bit of a hint of which company is actually cheaper. I don't want to make a huge table, so I'm going to skip to 15 where I know that they're going to be the same. I'm going to use this table to give me some clues about what's happening. Then I'm going to use 16. And the table's not going to stop at 16. So then I'm just going to continue. And that's going to be our layout of the table. So we know that with Print It, it's $21 for the first jersey. With Top Print, it's 18 plus 45 for the first jersey, which is going to give us $63. Then for each additional jersey we printed, it's $21. So if we fill this out, we have 42. Then we have 63, 84, 105. For 15 jerseys, we do have to do 15 times 21, which is going to give us 315. And then we have 336. With that, our top print, all we have to do is add 18 to each of our jerseys. That's going to give us 63 plus 18 is 81. Then 99. Then 117. Then 135. If we figure it out for 15, plug 15 in for x, we're going to get out 315, which is good because we saw that at 15 they should be the same, which they are. If we add another one, we're going to end up with 334. So what we can see is when should we choose Print It? We should choose Print It anywhere we're going to make less than 15 jerseys. We'll see that it's going to continue being cheaper after 15 for our top print. So when should we choose top print? When we're going to be making more than 15 jerseys. When we're making 15 jerseys, it doesn't matter. They're the same price at 15. But those are the conditions that we need to use. So for B, they're saying a third company called Value Printing wants its prices to be in between those of Print It and Top Print. The company never wants to be the cheapest nor the most expensive. Complete the poster for the new company. Show work. So, with that, I knew that the price per jersey had to be in between 21 and 18. But if I only use something that's in between 21 and 18, initially it's going to be cheaper than Print It. So in addition to being in between 18 and 21 per jersey, I need to have some initial fee that is going to bring it to be higher than the 21. So I started playing with numbers. I said, all right, well, why don't I try y is equal to $19 per jersey plus initial fee of 20. So when I did that, that means that the first jersey is going to end up being 39, which is fine. Then when I kept playing around with it, we have to add 19 to each of them. So I said, all right, 39. That's going to give me 58. So far, so good, and keep playing with it. So if we keep playing it with it, we'll see. We start with, going to make a little table for myself. This is value printing. X. So we have 1, 39, 2 is 58, which if we take a look at so far so good. Then 3 is going to bring us to, we have to add 19, that's going to end up being 77. So far so good, still in between. Then with 4, that's going to add another 19, so that's going to end up being 96. So far so good. 5, we have to add another 19, so that's going to end up being 115. So far so good, still in between. Then I'm going to check to see what it is at 15. So when I check to see what it is at 15, I'm going to have to do 19 times 15, which is going to be 15 less than 300. So it's going to end up being 285. Then I have to add 20. So 285 plus 20 is only going to bring to 305. That's not good, because I don't want it to be cheaper, and here it's cheaper. So I see that I have to add something else to it. So then my next try was, all right, well, if that's not good, let me try y is equal to 19x plus 30. Because then if I have plus 30, that's 10 more. At this point, it's going to be 315. It's not cheaper or more expensive. So when I did that and I made my table here, I found out that with this number, I'm just going to carry it down here. I ended up with 49 for 2, 68. It's just adding 10 to our previous values. Then 87, 106, 125. Then at 15, it ended up being 315. And I had to check one more. So at 16, it ended up giving me 334, which we see is in between. Sorry, this was 333. My bad on that. Which is right in between both of these values. And we'll see that because this number we keep on adding 18, this number we keep on adding 19, it's going to work for a while, at which this number is adding one more, so it's always going to stay one more big above this. So if we do the next one, we'll see we have to add 18. That's going to end up being 300, and we're adding 18. That's going to bring it to 41, 351. Where over here, if we add 19, that's going to bring it to 353. So we see that this was 1 over. Now it's 2 over, because this was 1 higher. So in this way, we have our winner. This is going to stay in between both of them, adding 21 and adding 18. If anyone has any questions, please let me know. I'm going to be doing a Google Meet at 11. So if you have any questions, please ask. We found out that the one cost we can use 30, and each jersey the price would be $19. So again, if you have any questions, please make sure you ask either in Google Meet or on Google Classroom. Thank you.